look at hyperbolic trigonometric functions, which are more frequently called hyperbolic functions. The relationships between the hyperbolic functions are very similar to the relationships between trigonometric functions, where the hyperbolic sine of x divided by the hyperbolic cosine of x is equal to the hyperbolic tangent of x. These three are the definitions that we use in order to evaluate hyperbolic functions. Sometimes we like to rewrite these so that we don't have that large fraction, and instead we have 1/2 times the quantity e to the x minus e to the negative x for the hyperbolic sine of x, or 1/2 times the quantity e to the x plus e to the negative x for the hyperbolic cosine of x. You see hyperbolic functions come up in engineering, perhaps if we're modeling the way that a wire would hang. They also show up in some differential equations, particularly as solutions to differential equations. Whereas trigonometric functions have a unit circle, hyperbolic functions have a unit hyperbola. The derivatives of hyperbolic functions are similar to the derivatives of trig functions, with a key difference. Notice that the derivative of the hyperbolic cosine of x is equal to the positive hyperbolic sine of x. The derivative of regular cosine of x is equal to negative sine of x. So you want to be really, really careful that you're not mixing up the rules between these two types of functions. Now let's use our definitions in order to evaluate some hyperbolic expressions. First, we want to find the hyperbolic tangent of 0. The hyperbolic tangent is equal to the hyperbolic sine of x, in this case 0, over the hyperbolic cosine of x, so the hyperbolic cosine of 0. This is equal to 1/2 times e to the x minus e to the negative x. So 1/2 times e to the 0 minus e to the negative 0 over, and now we have the hyperbolic cosine, so that's 1/2 e to the 0 plus e to the negative 0. Our 1/2s will divide up, so we are left with e to the 0, which is 1, minus e to the negative 0, which is also 1, over 1 plus 1, which is equal to 0 over 2, which is 0. So the hyperbolic tangent of 0 is 0. We also have inverse hyperbolic functions. So if we want to find the inverse hyperbolic tangent of 0, it helps to think of this as equal to some number. So the inverse hyperbolic tangent of 0 is equal to some number x. And then the inverse of the inverse hyperbolic functions are just the hyperbolic functions. So we can take the hyperbolic tangent of both sides. So we have the hyperbolic tangent of the inverse hyperbolic tangent of 0 is equal to the hyperbolic tangent of some number, where these two functions are inverses, so they'll cancel out, and we're left with 0, is equal to the hyperbolic tangent of some number. This is slightly easier to reason about, because we just found that 0 is equal to the hyperbolic tangent of 0. So that x that we're looking for is 0. So the inverse hyperbolic tangent of 0 is equal to 0. Now let's find the hyperbolic sine of 0. This will be equal to 1/2 times e to the 0 minus e to the negative 0, which is equal to 1/2. E to the 0 is equal to 1 minus e to the negative 0, which is also 1. This simplifies to 0. So the hyperbolic sine of 0 is 0. Now we want to find the inverse. So the inverse hyperbolic sine of 0 is equal to some number x. So the hyperbolic sine of the inverse hyperbolic sine of 0 is equal to the hyperbolic sine of some number. Our functions will cancel out since they are inverses. So we have 0 is equal to the hyperbolic sine of some number, which is a little easier to think about. We just found that the hyperbolic sine of 0 is equal to 0. So that is the unknown number we are looking for, and the inverse hyperbolic sine of 0 is equal to 0. Let's look at the hyperbolic cosine of 0. This will be equal to 1/2 times e to the 0 plus e to the negative 0, which is equal to 1/2 times 1 plus 1. So that's 1/2 times 2, which is equivalent to 1. Now we want to find the inverse hyperbolic cosine of 1, which will be equal to some number, which we will call x. Then we can take the hyperbolic cosine of both sides. So the hyperbolic cosine of the inverse hyperbolic cosine of 1 is equal to the hyperbolic cosine of x. Our two functions cancel, and we're left with 1 is equal to the hyperbolic cosine of some number x. We just found that the hyperbolic cosine of 0 is equal to 1. So 0 is that x that we are looking for, and the inverse hyperbolic cosine of 1 is equal to 0. Next up we have the hyperbolic secant of 0. The hyperbolic secant of 0 is equal to 1 over the hyperbolic cosine of 0. We just found the hyperbolic cosine of 0 is equal to 1. So we have 1 over 1, which is equal to 1. So the hyperbolic secant of 0 is equal to 1. Next we have something a little bit different. Now we have the hyperbolic cosine of the natural log of 2. This is equal to 1/2 times e to the natural log of 2 plus e to the negative natural log of 2. The most common mistake I see is with that negative exponent. You want to keep in mind that this is the same thing as e to the natural log of 2 to the negative 1. So that's e to the natural log of 1/2. So we have 1/2 times e to the natural log of 2, where the e and natural log cancel out. So we're left with 2 plus 1/2. So this is equal to 1/2 times the quantity of 2 plus 1/2. 2 is 4 over 2, so we have 4 plus 1 is 5 over 2, which is equal to 5/4. So the hyperbolic cosine of the natural log of 2 is equal to 5, I don't know where I wrote 2, 5/4. Now let's find the hyperbolic sine of the natural log of 4. This is equal to 1/2 times e to the natural log of 4 minus e to the negative natural log of 4. Being careful with that negative exponent. So this is equal to e to the natural log of 1/4 So we have 1/2 times 4 minus 1/4. So that's equal to 1/2 times 16 over 4 minus 1 over 4, which is 15/4. 1/2 times 15/4 is equal to 15/8. So the hyperbolic sine of the natural log of 4 is 15/8. Now let's find the hyperbolic cosine of 2. This is equal to 1/2 times e to the 2 plus e to the negative 2, which is equal to 1/2 e squared plus, continuing to distribute that 1/2, and rewriting that e to the negative 2 as 1 over e to the 2. So we have 1 over 2 e squared, which is a little long for that. For these last two, we have the hyperbolic cosine of the natural log of 3, which will be equal to 1/2 times e to the natural log of 3 plus e to the negative natural log of 3, where that e to the negative natural log of 3 is equal to e to the natural log of 1/3. So this whole thing is equal to 1/2 times 3 plus 1/3, which is equal to 1/2 plus 9/3. 1/2 times 9/3 plus 1/3, which is equal to 10/3, which simplifies to 5/3. So the hyperbolic cosine of the natural log of 3 is equal to 5/3. Then finally we have the hyperbolic sine of 3, which is equal to 1/2 times e to the third minus e to the negative third, which is equal to 1/2 e to the third minus 1 over 2 e cubed. In the next video, we'll look at how to find the derivatives of the hyperbolic functions.